In 2003, a New Zealand Linux distribution topped DistroWatch. Not Red Hat, not SUSE. Something compiled in a cave under an Auckland house. The argument that got Yoper to global #1 is now defining whether your AI model is genuinely open source. Bazaar has no head office. Only one question: is the technical reality good enough? Yoper compiled for i686, pre-linked the binaries, and beat every major distribution on application launch time. Community found it. 4 months at #1 on the weekly charts. But Ubuntu arrived in 2004, the performance gap closed and the niche disappeared. The open source initiative released OSAID 1.0, the AI equivalent of the GPL. Both major models fail it. Meta is doing what SCO attempted in 2003, redefining the terms to...
Let's get into it.
This is a concise history of Linux. Episode 12. The performance gap in desktop Linux in the early 2000s had a specific cause. Most distributions compiled for 386, the Intel baseline from the late 1980s. It ran everywhere. It was also slower than necessary on hardware that was already 20 years newer than the architecture it was optimizing for. I had been thinking about this problem since my time at Telecom Extra in the early 2000s. Desktop Linux was losing the enthusiasm contest to Windows XP, while server Linux was quietly winning the Enterprise one. The gap between them was not inevitable. It was a choice nobody had bothered to reverse. In 2003, in a cave under an Auckland bungalow, I built the answer. By 2003, i686 was what people owned. Compiling specifically for i686 with the instruction set extensions that architecture supported, produced binaries that ran measurably faster. This was not a marginal improvement. You could feel it in application launch times. Pre-linking extended the argument. When a Linux application launches, the dynamic linker maps shared libraries into memory at runtime, adding measurable latency on every execution. Pre-linking pre-processes that mapping at install time. The runtime cost largely disappears. Ship pre-linked binaries compiled for i686, and the user experience is something the desktop Linux community had not seen before. Genuine speed on a general-purpose machine. We honestly claimed what the performance justified. Yoper was the fastest out-of-the-box desktop Linux available. This mattered for a practical reason. If the operating system launched applications more slowly than Windows, the conversation ended before it started. Speed was the prerequisite for the argument. Yoper made the argument defensible. I was building Yoper while working at IBM to deliver the platform Air New Zealand would use for their online ticketing. Every evening, descending into a cave under that Auckland house, compile a distribution that was outperforming Red Hat and SUSE in community rankings. From March to June 2003, Yoper was #1 on DistroWatch's weekly rankings. The 2003 annual aggregate placed Yoper 6th overall with 390 page hits per day behind Mandrake's 770. But the 4-month window at the top of the weekly chart said something the annual table could not. At the moment, the community was paying closest attention to desktop performance, and New Zealand distribution was their first choice. Geographic origin was irrelevant to DistroWatch rankings. The Bazaar has no head office. Technical excellence built without corporate resources competes with distributions backed by hundreds of engineers. Every distribution eventually finds its limits. When I joined Novell full-time and wanted to concentrate fully on selling SUSE, I handed Yoper to Tobias Gershner. He ran it for a period. He later decided to discontinue it. Ubuntu arrived in 2004 and changed the calculus for general-purpose desktop Linux permanently. The performance niche Yoper had carved became less differentiated as base distributions improved their compilation defaults. The transition to 64-bit architecture also reduced some of the specific edge that i686 optimization provided. Running a distribution teaches things you cannot learn from using one. Packaging is a design discipline, not a maintenance task. Community trust accumulates over releases, not announcements. Sometime later, at LinuxConf Australia, that conversation belongs to episode 13. What mattered in that moment was the same thing that mattered when the DistroWatch ranking first loaded. Someone in the community had noticed. In April 2026, the AI model landscape has fractured into exactly the contested terrain that Linux occupied in 2003. 6 major labs now ship competitive open-weight models. The licensing has divided into 2 positions. On one side, Apache 2.0 and MIT, Gemma 4, Qwen 3.6, Mistral Small 4, GLM5, DeepSeek, permissive, no commercial thresholds, no downstream obligations. On the other, Meta's community license, commercial use permitted unless your organization exceeds 700 million monthly active users. Multimodal capabilities prohibited for EU deployments. All derivative models must carry, built with Llama, attribution. Open weight is not open source. The terms determine what you can build, where you can deploy it, and what obligations you carry forward. The Open Source Initiative released OSIE 1.0 in October 2024, the AI equivalent of the GPL, a definition of what open source actually requires for AI models, covering training data provenance, complete source code under an approved license, and model weights under approved terms. By that standard, only around 5 models currently qualify: Pythia, Olemo, Amber, Crystal Coder, T5. Every major commercial open-weight model, including Llama 4, Mistral, and Qwen, fails on at least one element. The parallel to 2003 is direct. Then, SEO was trying to redefine the legal meaning of Linux code ownership. Now, Meta is refusing to accept the community's definition of open source for AI, continuing to market Llama as open source despite OSI's contrary determination. Google and Microsoft agreed to stop using the term for restricted models. Meta did not. One complication the GPL era did not have: the OSI's own governance process collapsed in late 2025 amid transparency concerns, with board elections suspended and a redesign announced. The governance commons is being built under fire. Again, for boards approving AI procurement, OSAID compliance is becoming the new license audit. For architects, OSAID's 3-element definition, covering training data, source code, and model weights, is a structural completeness standard. If you cannot specify all 3, the architecture is not auditable. The same provenance logic that Vera applies to reasoning chains applies here too. If you cannot inspect the training data, you cannot verify the outputs. Yoper never had to answer the governance question. The GPL had already answered it for Linux. The community that built a world-ranking distribution in a cave in Auckland without a corporate sales team is the same community now being asked to hold the line on what open means for AI. The OSID question will be settled the same way the GPL question was settled, by community adoption, not by legal orders. Enterprises that insist on OSID-compliant models will pull the market toward the standard. Enterprises that accept open washing as a substitute for genuine openness will subsidize the erosion of it. What do you think it takes for a governance framework to actually stick? What made the GPL work when so much else failed?
That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.